everyone. Good to see you. It's a big trip from Australia, 16,000 kilometers. I believe my presentation will be very complementary to what have been said already. And it's great to see that so many people working in the same direction. So I want to share with you how we do threat report processing and how we use machine learning AI, where it's better to use one or another. And let's begin. So let's start with the our daily things. That unfortunately, many companies, people still spend a lot of time assessing what's relevant to the organization, reading a lot of numerous reports every day, and there are many ways to kind of handle that. And we said to ourselves, what if we can create a tool which can do pre-screening of all reports and allow you to filter out the relevant ones and focus on the things that really matter. So according to the statistics we have, there's many articles, news, which have information related to threat intelligence, but most of them are reposts or somehow a summary posted somewhere, and then there's a reference to the original text. So it's important to narrow it down to the actual reports, which are rich with information and have some technical details in it. So for the last year, we found that there was around 50,000 reports we have to be checking, and only 2,200 out of those were actually something useful for DFIR guys, for SOC people to use it in their daily job. So as a CTI function, you would love to have this information and to disseminate to them, right? And even if you have resources to read all that, then you kind of need to analyze that, and it takes even more time. It may be that out of this, around 16, reports, which has some real information in there, none of those could be, something that you would like to have applied in your organization, because the applicability is the other thing. So who are these entities, who are these bodies who produce content? So there's, of course, government agencies in different countries, there are different agencies there issuing this on periodically, weekly, monthly, or on a case. There's security centers everywhere. Different vendors, either specializing in threat intelligence or producing security products. And also there's so many people all around the world speaking all different languages who just want to share what they found. Someone just dropped malware into sandbox, analyze that behavior, then dig a bit more and publish their analysis. And it's also interesting to see how it's happening in different parts of the world. If you analyze WeChat, you then see how what they do and how they track, India threat actors. Or if you start looking into information published in the Spanish world or in Russian and so on, you can have a comprehensive picture. So the idea is that, first of all, we need to identify from where we can get this data, and then understand how we can classify, because processing all of that will be very expensive. So in order to filter out irrelevant information, there needs to be some classification mechanism. I'll be talking later about how to classify data. And then to classify, you need to understand how to measure the richness of this article or report. And to do that, what we do, we extract different features which describe the report, whether you have information about threat actor, tools, malware, some information which gives you understanding what's happening. Some of these elements which are being analyzed are on the screen. So today, I want to talk about the stages, what we do in order to process threat reports and transform them from human-readable reports into STIX 2.1. And there are also other ways to represent data, but it's just one of the ways to do that. It could be MISP, it could be another human-readable report, but you may want to transform a report published by a vendor into your own corporate standard and then disseminate it in a way which will be understood by all the recipients within your organization. So Yeah, machine learning and LLM could be used at different stages. I'll be covering a couple of those just because I don't have time for everything. So the first thing is to actually download, and it takes time just because there are many obstacles on this road, and unfortunately, not everything is kind of easy to download. There's always errors. You need to have a lot of parsers. You need to do pre-translation. If you download information from Chinese blogs, for example, or you take in information from Russian sources, then in order to make sure that you then process everything in normalized way, you kind of need to map it to a certain schema, which you maintain as well internally. And once you've got all the documents collected, the next step is tokenization. So colleagues have already mentioned Spacey as an example of a library, but there are many methods to do this named entity recognition. So next slide, I'll show in details how it works. And when you extract these entities, you will find that some of those actually you know, and some of the entities are known. It happens that, you know, different vendors, security vendors, they name threat actor in one way, then they suddenly decide to change their naming conventions, and you gotta have a lot of aliases, and the same malware can be named differently with different aliases depending on what company found it or how they track that along the road. And also, there's also variants of software. So, you know, Mirai has a lot of variants, and each new variant you kind of need to link to the original one, and that requires you to maintain a certain knowledge base to ensure that an entity which is extracted is not something unique, but actually it's just an alias of an existing entity you know. So once you've got all these features extracted, next step is to classify. So in our case, we use cat-boost classifier, which allows you, like it's a decision tree, it allows you to understand if something is fit to a certain bucket. So what we do, we just aiming to classify into 3 buckets, whether it's a strategic TI report, something talking about trends, about big things like where we're going, and tactical operational reports. That's where we'll have information about behavior, and plus we may have some like little atomic details, right? Like IOCs and so on. So this is another bucket, and the third bucket is everything else. That's to be filtered out, and to ensure that we don't spend a lot of resources processing information where you have the report, you know, threat actor is mentioned, but that's it. There's nothing more around that, right? And then there's just fluff describing some recent developments, and this will be like an article reposting some other, you know, information related to some regional report. So how does this process look like? So this is an imaginary kind of report generated by ChatGPT. So, and usually you have like a title and have a number of paragraphs, and at the bottom you have indicators, or you may have a link where you can download that. So your engine should also be able to follow those links to grab that additional data. It could be PDF, it could be GitHub, CSV, something like that, and then extract that and attach it to the original article, so then you can treat it as one thing. So idea is that you have an engine which goes through the text and marks all the different objects. So also you need to know, as I mentioned before, that the aliases. So if you see that here, if you don't kind of know that this imaginary threat actor, Dark Phoenix, is the same as a frozen cactus, then you could have 3 entities in the end, right? But in fact, it's just 2. So yeah, some entities easy to extract, like vulnerabilities. If you have a CV, it's just regex. For some of them, you would need some other technologies to use. So regexes do not work all the time, or they're error-prone, and you kind of need to have a lot of them, and then additional checks, and then many kind of work to be done to handle exceptions, right? So therefore, machine learning helps to do this name and recognition, or you can just ask ChatGPT. But if you start asking about each and every entity, it could cost you a lot. The other thing is good to track is time. So it's good to know whether it's recent information. In many reports, they just refer, so that threat actor behavior was like that last year, but now it's different. So when you build a STIX bundle, you kind of need to know whether it's relevant to now, whether it's a new information. And when you're human reading this report, it's easy to comprehend. Next thing is sectors and locations. So for sectors and locations, it's a bit easier just because the cardinality of this dictionary is kind of smaller, even though we have different variations. So like, for example, Germany can be, it could be a location name or a language or a nation mentioned, and then you can kind of map it to location. But sometimes if it says Chinese, you don't really know what, there are many people, Chinese people live in different countries, so you don't really know location. But sometimes you can guess. And then Germany, Allemagne, Deutschland, and so on. So many variations as well, but there are not so many, so it's kind of easier to handle. TTPs, I think, is the kind of the most complex one, as it requires you to map like a really, text to T code. And if you have a T code written in the text, it's easy to pick up by running a regex. But if it's a text to be mapped using machine learning, it kind of takes more time. So what we've done, we've collected a lot of data, labeled it, and using machine learning to kind of guess this T code. But it requires much more effort to maintain this one. Course of action, IOCs. With IOCs, it's tricky as well. So if you look at the software version here, do you think it's IOC or software version? If you just use the regex, it will pick up it as an IP address. But it's not. And you need to know the context, what words are close to that object. So if it's IP address, right, you would want to see IP or address or something. You could come up with such regexes to clarify these details, but there'll be so many, it's actually, hundreds and then thousands of regexes, which is very slow in the end and hard to maintain. So AI helps with that, so for example, because for AI, it's easy to pick up that it's a software version from the context. Cool, and that's how it works, but that's half of the way, right? So we've got only the tokens, so we've got the objects, but how we can then link them together. And this relationship problem is another thing we've been doing. And I'll just show you what are the ways to do name recognition with LLM, and then we go into the relationship thing. So why relationship is important? Just because, as you see here, the three threat actors mentioned, but is it article about, in that case, Dark Phoenix or Shadowgate, or is it, or is it about Shadowgate, or is it Brown Eagle or something like that? So it's hard to guess without knowing the relationships. So ChatGPT, there are a couple of examples here on the screen. So 3.5 was used to kind of, with a simple prompt. Of course, you don't use it in production, but it's just to, visualize what you would see, right? So it's kind of good at grasping the threat actor names. It sometimes identify correct malware names, but the idea is that how you then can find that particular part of the text where it was found, right? So you need then to do some other query to LLM to ask, please provide me an extract of that particular sentence where you found it. Or you can define an assistant in a way so that you'll be providing an example and then asking to give you an answer which will be following your example. So it's okay in terms of parsing locations or sectors. Sometimes it makes mistakes. So like if you put temperature too high, then it will start being more creative in terms of naming of this sector, so better to keep the temperature low for this kind of questions. And also mapping of this threat names or sectors or locations into your own dictionary would be harder if you had this temperature quite high. So ideally, you could integrate it with some API which will provide the dictionary, and then when you ask LLM, you actually give your own taxonomy and asking to map it into that taxonomy. That way, you get more consistent results, and the answers will be deterministic. With TTP's GPT 3.5 doesn't know what to do. It just extracts some random strings, and it's not really working. A course of action is also not good. With indicators, for example, it works okay, but you need to specify what's the format you expect from it. You see that the development of models is kind of quite rapid, and we constantly check and test all the models. And I see that it's getting there. So I feel like in a year we may be having a completely different kind of story, and we could use LLM more and replace some of the older mechanisms we use inside, like some of our static kind of mapping rejections and machine learning predictions. But also the other problem is that each run, it will give you different answers. So you ask a question once and give you an answer A, you run another one, it gives you answer B. And what's that point when you get all the possible answers, right? So if you start doing multiple runs in order to merge the results and figure out the best, where to stop, how many times you can do. And there's also restriction, cost prohibitive. It's cost prohibitive to continue running it every time. They could build some conversation logic, so you get an answer, and then you ask the model again, hey, double check that this output is in that particular format, and then it will fix itself. So it's very important to have this validation handlers enabled after you got the result. There's also RAG. When you have your vector database with all relevant information, and use that data to feed LLM to get better answers. So many technologies available. It's really interesting how the industry goes forward, and there's a lot of development there. In terms of classification, so that's named entity recognition, right? With a machine learning, we use as 98.5. With LLM, we cannot currently achieve that. So classification is still cheaper and kind of easier to do with machine learning. Model 3.5 is not really giving you good results. Next one gives you much better results, but then you run it once, it gives you one answer, another one, it gives you another answer, and it's really very random. And I think LLM also tends to give you the answer what you want. So it kind of tries to manipulate you or can lie to you. So it's also important how you create the prompt to ensure that you're not getting there's less bias in the response. Just to cover this particular topic, when name entity recognition classification, I believe here we still have space for both technologies, and the machine learning is still very good in terms of classification of reports and putting them into the separate buckets. LLM does a good job at extracting some part of the entities, but then it's harder to map them. And if you have data which you cannot export to the public system, then you might want to use some private LLM, which requires you either to commit to buying some cloud services or build your own physical infrastructure, and that's quite a bit commitment in terms of buying video cards and then setting up all this server infrastructure, ensuring that it's highly available and production ready. Okay, and now going back to these unknown entities. So here's an example of how some threat actor names could look like. There are some real ones and obviously some fake ones, right? But idea is that you could just use regex. This is usually either a word, bigram or trigram. Very rarely it's like 4. pieces of together, and there are many features you could use to describe that, but it's important to select the right features. Some features really don't give you much, in terms of usefulness of the output, right? So there's a certain capitalization pattern. Usually you have if you see that the word has a capital letter somewhere in the middle, right? It's also a good indicator. You may look not just at the particular word, but also check surroundings. Like you may want to see what are the words close to that word you're trying to classify, or are there any indicators of actions? Because if you try to classify a threat actor, for example, it's a subject doing something, right? If it's a malware, it's an object which is being used by someone. So that is also could be a feature which you can then feed into the model to make sure that you have a better classification result. So another experiment was with the open chat. So internally we still keep using OpenAI, but we're looking for other models. So idea is that for similar things, you could do a guesstimate kind of based on OpenChat, but for now, all unknown entities go through operators. So when we identify a known entity, we automate the classification by different mechanisms. But then, in the end of the day, a person looks through the list and accepts the ones which are correct. Okay, so we've got that down to a point that we have a model of the article with the objects mapped to different sentences, titles, and it's all organized in different paragraphs. But next thing is how to find relationships between them. So there are three kind of methods we have been using so far. One is, obviously keyword regex search. It sometimes still works, but it's error prone, and there's many exceptions, as I mentioned before. Another one is using vectors. So you would try to map a word into its vector representation, and then by using that and comparing, you could predict what relationship could be between the two objects. And the last one is LLM. Unfortunately, if we stick to STIX, for example, right, there's a certain finite number of relationships which could be between two different types of objects. So therefore, you could piggyback on this kind of existing taxonomy, kind of use it, but sometimes you may need something else, right? And it really depends on the use case. So if you do regexes, so what happens is that when you analyze threat reports, it could be active or passive voice, right? So you need to kind of check both sides when you write your regex. Also, part of the thing, like sometimes you have a malware name mentioned in the title, and then the actual description, what's happening, will be in the paragraph. And it could be not the first sentence, but the second one. So your regexes need to be taking care of this type of things, and you kind of need to merge different parts of the report before you can apply that regex. And it's really complicated, so it's like a dead end. If you kind of follow this path, you will stuck. So it's good to kind of begin threat report processing with this approach, but later on, it's just not really viable. The next thing is building relationships using ML. So as I said before, you would like to kind of try to map words into digits. Machines work with digits, and think of it as that way. So you have virus, network worm, Trojan, and so on. These are put on the one vector, and you have adversary, threat actor, or gang, on the other vector. So if you see certain words being used, interchangeably, they will tend to be on the same kind of vector on the graph, right? That's how kind of the logic works at the back end, right? And you map different texts by labeling, annotating your corpus of data, and then kind of train your model. And eventually, what it does, it's able to predict with a certain quality, of course, relationships. And so currently we see that this process is very expensive for us, so we better use LLMs. And here you have a lot of options to kind of make the system doing this better. So that, like some relationships are created by regex. Some are created by ML, but the more complex ones, which require more sophisticated kind of approach, or we use LLM for that. So idea here is that the problematic one is like cost and time and error handling. So when you ask LLM, it may wait for it may take time to process. So you kind of need to align all your timeouts in every part of the software to ensure that it could wait enough time. And then if you have this validators, if something goes wrong, you need to resubmit your query. And so this quality checking, waiting kind of slows down the whole pipeline. So it means you consume more memory, and it requires you to have more processing power involved in the process. But in the end, when you kind of do pre-filtering right, you'll be not having so many reports at this stage already, because this will be filtered by classification at the third step. Billing, so in every module in our software, we have a small login module which records how many tokens each part of the software used. Therefore, later on, when we do analysis why the bill is so high, we can check what particular part of a pipeline, consuming how many tokens, and then therefore we can optimize that particular part. So in terms of relationships, I believe the future is LLM, and I see that this rapid development actually indicates that maybe really next year when we can internally stop using most of these old technologies and switch to LLM. And the last one is about data representation. So once you have that graph built internally, to transform it in any machine-readable format, you don't need much, right? So it's just pure kind of code to be developed to do this one-to-one mapping. It's sometimes hard when you try to map to different standards, just because the way how MISP is structured is completely different to the way how STIX is structured. So it's kind of a challenge sometimes to map it, but it's more like a challenge for a programmer. If you want to do something which will be human readable, LLM is really helpful here. And so in terms of translation, for example, when we do pre-translation, we use APIs, but when we push it to the user, we give the original text, the text which is translated by the API, which is paid API, the menu out there, and then we ask LLM, hey, have a look, and if there's any, sometimes when you translate from Russian or from Chinese, you read that in English and it's kind of a bit weird. So LLM can help to make that text more readable. So today I think there's no issue translating almost any language into English. Summarization is not a problem as well, so it works quite reliably, and you don't need very special models of that. So for things like relationship extraction, it's better to have a kind of customized model, but for summarization, it works out of box. Some other things I've heard yesterday, for example, people still create graphs manually, but there's a meme-made code, so LLM can generate you this code, and it's a way to draw automatically different charts, flow charts, graphs, mind maps. So it's really cool, and LLM can really automate creating graphs for you in the format you like. And the last thing is about creating your own templates. Because in every same function you would have some templates how you want to present data internally. So LLM also helpful in that case. Just to finish, I'm showing you an example how the recent Palo Alto report, this vulnerability can be translated into STIX. That's how it looks in STIX, and that's what engine currently does. So it extracted the campaign, TTPs, CVE indicators, how they interrelated, and the actual backdoor. Cool. That's it. Thank you very much.